Hello dear friends. In this video, we will see how to maximize revenue using assignment technique. For this, we will take one question. Three different salesmen X, Y, and Z are to be assigned to three different regions A, B, and C so that the company's revenue is maximized. The following matrix gives the sales revenue. So you know that A, B, and C are the regions and X, Y, and Z are the salesmen. So if you appoint X to region A, the sales will be 10. If you appoint X to region B, sales will be 20. If you appoint X to region C, it will be 60 and so on for the others. You're required to use the assignment technique to maximize the revenue. So the first step is you have to find out or you have to identify what is your objective. Now in this question, objective is maximization. What is objective? It is maximization is your objective. And then the second one is identify the nature of data. Now, what is the nature of data? You know that there are three rows and there are three columns. So the data is balanced because there are three rows and there are three columns. Number of rows is equal to the number of columns. Therefore, the data is balanced. And remember, whenever there is a maximization problem, so what we have to do is we have to convert this matrix, whatever is given, that matrix you have to convert it to opportunity loss matrix. So how to do that, we will see now. So first step is identify the objective. The objective is maximization. Because the objective is maximization, you must know that we have to find out or we have to prepare the opportunity loss matrix first. Then we know what is the nature of data. The nature of data is balanced because the number of rows is equal to the number of columns. Now we will start with the problem. So first we have identified the objective. Second one, we know what is the nature of data. Nature of data is balanced. Now the matrix given in the question, I have copied it here. 10, 60, 30, 20, 30, 15, 60, 40, 10. So what is the third step? The third step is to create the opportunity loss matrix. Now, how do we create the opportunity loss matrix? In the matrix, what is given to you? You see the one which is the highest value here. What is the highest value? The highest value is 60. 60 is the highest value in this particular matrix. So highest element in the matrix is 60. How do you calculate the opportunity loss matrix? Opportunity loss matrix is equal to the highest value minus the element in the matrix. So in other words, it is 60 minus 10, 60 minus 60, 60 minus 30, 60 minus 20, 60 minus 30, 60 minus 15, 60 minus 60, 60 minus 40, 60 minus 10. So this is what we are going to do here. So the highest element in the matrix is 60. How do you calculate the opportunity loss matrix? It will be 60, the highest element, minus the element in that particular matrix. So when you do that, you will get these values. This is called the opportunity loss matrix. So once you have created the opportunity loss matrix, then normally what you do for minimization problem, the same rules you have to follow here. So the first one is the row operation. So to do the row operation, you have to see in the first row, which is the least value cell. So the least value is 0. In the first row, the least value is 0. The second row, the least value is 30. Third row, what is the least value? It is 0. Okay, now how do you do the row operation? Row operation will be the element in the matrix minus the row minimum. This is what is row operation. So what do we do? It will be 50 minus 0, 0 minus 0, and 30 minus 0. That's what I have done. Now, when I come to the second row, see what is the element here. It is 40 minus, what is the row minimum? Row minimum is 30. So what I'm going to, we're doing 40 minus 10, sorry, 40 minus 30, 30 minus 30, and 45 minus 30, because 30 is the row minimum. So this you have to do it for the second row. After you finish with the second row, third row will be whatever the element minus the row minimum is 0. Therefore, if you do this, you will get what? This is 0 minus 0 is 0, 20 minus 0 is 0, 50 minus 0 is 50. 0 minus 0 is 0, 20 minus 0 is 20, 50 minus 0 is 50. Now, after you do this, you have to do the column operation. To do the column operation, what should you do? First one is see the first column. See what is the least element in the first column. First column, the least value is 0. Now come to the second column. See what is the least value. Least value is 0. Come to the third column. See what is the least value. It is 15. So write here 15. So how do you do the column operation? Column operation will be, so it is the element minus the column minimum. Column minimum is 0 in this case. So what do you do? 50 minus 0, 10 minus 0, and 0 minus 0. So column minimum. So first column I have done. Now come to the second column. Second column will be 0 minus 0. You know what it is. 0 minus 0 is 0. 0 minus 0 is 0. And 20 minus 0 is 20. So 0 minus 0 minus 0 minus 0. Now what is the third one? Third one, the column minimum is 15. So from here, 30 minus 15, 15 minus 15, 50 minus 15. So what do we do here? It is 30 minus 15. So row operation and the column operation is done. After you have done with the column operation and the row operation and column operation, then we have to check whether the matrix that you have obtained is feasible for optimal assignment. So that is called optimality test. So what do we do? I will copy this matrix as it is. I will copy the matrix as it is. So I've copied. Now what I will do is I will draw lines to cover maximum number of zeros. So see here in the first row, there's only 1 0. Second row, there are 2 zeros. Third row, there's 1 0. Column wise, if you see 1 and here 2 and here 1 0. So if I draw a line this way, it covers 2 zeros. Okay, so I've drawn one line to cover 2 zeros. If I draw one line this way, it covers 2 zeros. Now this 0 is pending. You can draw the vertical line or a horizontal line. So the number of lines drawn, okay, is equal to the order of the matrix. So if the number of lines drawn is equal to the order of the matrix, that means it is possible for optimal assignment. That means this matrix can be used for optimal assignment. Supposing if the number of lines drawn is not equal to the order of the matrix, then you will have to revise the matrix. That we have already seen how to revise the matrix in the previous uh, video. Okay, so now we will make the optimal assignment. So I will copy the matrix again. The same matrix what I have got here, that matrix I have copied it here. So optimal assignment A, B, and C, X, Y, and Z. Now I have copied the matrix. You must find out a particular row or a column which has only 1 0 in it. So I'm seeing the first row. In the first row, there's only 1 0. So put a box for that particular 0. So that means I am assigning A and Y. So Y is the salesman. Y will be assigned with region A. Do you understand? Therefore, Y cannot be assigned to any other region. Therefore, if there is any zero in that particular column, you need to strike it off. Now I come to the second row. Second row, now there's only 1 0, you assign it. And the third row, there's only 1 0, you assign it. So that means Y will be assigned with region A. Okay. Z will be assigned to region B and X will be assigned to region C. So optimal assignment, we will see now. A will be assigned, region A will be assigned to salesman Y. Region B will be assigned to salesman Z and C region will be assigned to salesman X. Now, what you have to do is, what is the maximum sales if you assign? Now, you have to go to the original question and see if region A is assigned to Y, what is the sales? The sales is 60, so you have to write here 60. Now come to the second one, B region if you assign to Z. So this is B region. If you assign to Z, what is the sales? Sales is 15. So here you will write 15. And C is assigned to X. Region C is assigned to X. X is 60. So right here 60. So what is the maximum sales if you do this? It is rupees 135. I hope you have understood how to solve maximization problem using assignment technique. Thank you very much for watching my video. Have a great day. God bless.